Hello and welcome back to another LeetCode video. Today we're looking at LeetCode's 3360 stone removal game. It's an easy problem, and again we're going to use it for interview preparation practice. Not to practice solving the most difficult problems, but to practice the LeetCode interview process. Or to practice the interview process with LeetCode. Right, so step one, let's understand the problem. And let's be vocal about what we do. So Alice and Bob are playing a game where they take turns removing stones from a pile, with Alice going first. Alice starts by removing exactly 10 stones on her first turn. For each subsequent turn, each player removes exactly one fewer stone than the previous opponent. The player who cannot make a move loses the game. Given a positive integer n, return true if Alice wins the game and false otherwise. Okay. So this looks like something we could implement straight away with an iterative approach where we let each player take a turn, and when one player can take a turn, we would just abort and return true if that player was not Alice, otherwise false. And constraints are, well, our input value n is between 1 and 50. Right. So I guess because we have a constraint on the input size, that automatically makes all of our approaches constant space and constant time as well. Now, if the problem, and this is just FYI, if the problem didn't have an upper constraint, maybe the first number of stones removed was also another input value, then we would have a more interesting runtime space complexity analysis, because we start to remove 10, then 9, then 8, etc., etc. That's also constant, can replace with the constant number of steps. That's still going to be constant space and time. So for this to be a problem that has an interesting runtime space complex analysis, both n and the starting number of stones to remove need to be unlimited and input parameters, right? Anyway, so yeah, so in an interview you would ask, what values of n do we get, and all of that goes good things. Constraints tell us the answer, so n is at least 1. Now let's look at an example. So Alice would take 10 away from the pile, and then Bob would have to try to take 9, but it can't, so Alice wins. Now, other example, there's only 1 stone, but Alice can take 10 stones from the pile, so Alice wins. And that's why Alice loses, so that's why we return false. Cool, so there is probably going to be like a closed form solution that gives you the result with a mathematical expression. But since, well, in an interview, you're not really going to be asked problems where you need to be mathematically, I guess, inclined to solve them. So for interview practice, we're not going to look for any such solutions. And besides, our runtime and space complex is already O of 1 and O of 1 space, time, and space anyway, so why should we try to make the life more complicated for us? So I think the straightforward way to do this is to just implement this logic, and we start with the value 10, and then we keep track of how many stones need to be removed in the next turn, and we just keep track of who is the next player to return either true or false. And that's exactly what we're going to do. So in the interview, I'll ask if it's fine if I implement that approach, and maybe there are some questions, clarifying questions that they have. Then you answer those questions, and then they say you can implement it. So in the beginning, we know that we can take away 10 stones from the pile. So that's going to be stored in a variable. Now I'm also going to store whether Alice wins or not. And that is just going to be a flag that we're going to flip-flop every time a turn is taken. And then at the very end, we just return turn Alice wins. Right. Now while, well, how long does the game last? Well, as long as we have more stones on the pile than we want to take in the next turn. Right? And now what do we need to do? Well, we need to flip-flop our Alice wins flag, like so. And then we just reduce the pile by k, and we need to reduce the amount of stones to take in the next turn by 1. Now, because n is at most 50, it's guaranteed that we're going to reach that point where, well, n larger or equal than k is true. And so after 10 steps, k becomes 0, And that's when we're going to exit here. Right, so we don't have to actually do any other checks, you know, whether, I mean, that's pretty much it. So it's always guaranteed to terminate because of the constraints and because n decreases faster than k. And when k becomes 0, that is when we automatically break out. That's the last, I guess, well, it's a guaranteed last point where we would guaranteed exit the while loop, so to say, yeah. And anyway, so this is it. That's the entire thing. So let's run it through the test cases. In an interview, you would take yourself a little bit more time maybe, and go through this code with exactly those examples. You could also ask whether you could write some test code, and but in LeetCode we already have that built for us. So those are the tests, and it seems like our 2 examples pass. Fantastic. So now let's submit the solution to see if it passes all of the tests, and it actually does. So that's very nice. And that, I guess, concludes this problem.